Ashan, live, let's go.
Good morning, good evening, based on the time zone, and welcome everyone to an interactive virtual fireside chat. I am Hassan Sheikh, CST 2002 batch of IIEST. I am based out of Seattle. I'll be the moderator for today's session. As a part of IIST Alumni Network Program, we have created three special interest groups. We call them SIGs. Computer science and data science is one of them. And today's event is the first event for the SIG. Today's topic is data science, future, and how to prepare. It was the most voted topic in our group. We have three alumni speakers today. They represent Silicon Valley, USA, and Silicon Valley of India, Bangalore. They will provide us unique insights for two distinct audience groups: those who want to start a career in data science and those who are seeking to switch career in data science field. Today's topic, we will also have question and answer sessions at the end or in between. You can submit your questions in the Zoom chat. We will take those questions during the session. Now, let me introduce our speakers. Our first speaker is Dr. Shomit Choudhury. Shomit Da is a big data, machine learning, and silicon design expert. He is the head of engineering at Amazon Web Services. He has led and founded several startups in the field of machine learning, both hardware and software. NVXL and web computing are two of them. Shomit Da is 1987 ETC graduate from our college. He did his MTech from IIT Kanpur and PhD from RPI New York. Welcome, Shomit Da.
Thank you, Hashan.
Our second
Thank you,
speaker.
everybody.
Thank you. Our second speaker is Mr. Chiranjeev Bhandari. Chiranjeev Da is the CTO of Avensus, an AI product software company for predictive maintenance of communication network. He has 30 years of research and development expertise in AI, telecommunication, operations support system related softwares. He also has a solid background in mathematics, statistics, and software development. He holds 8 US patents in machine learning algorithm. Chiranjeev Da is 1992 mechanical graduate from our college. He studied further in IIM Mumbai thereafter. Thank you, Chiranjeev Da, for joining us.
Thanks.
Our final speaker, Dr. Ritendra Datta. Ritendra is the Senior Director of Engineering and Head of Applied AI at Databricks, a startup that provides cloud-based data and AI solutions. He has worked at Facebook and Google and has a PhD in computer science from Penn State. He is an expert in statistical modeling, machine learning, and AI. He is currently working on generative AI and large language models for conversational agents and coding copilot. He is also a creative artist who work on films, theater, music, and writing. He is from 2004 IT batch from our college. Welcome, Ritendra.
Thank you so much.
Everyone, please welcome our awesome speakers. We will start our discussion to understand data science from a global perspective. And today we have global audience. Shomit Da, I will request you to share your insights into data science and AI trend. As you have been living in San Francisco Bay Area for more than 3 decades now, you have seen many technical evaluations. How do you see data science emerging in Silicon Valley? Shomit Da.
Thank you again, Hashan. Yeah, so in some ways, the reach of data science has expanded. So with growth of data, algorithms, processing speeds, more industries are using data. Now, it's the technologies and tools used by data scientists are changing. For example, if we look at the data side, we have seen the evolution from SQL to NoSQL, then data warehouses to data lakes to data lake houses. So a few years ago, people thought, usage of SQL will slowly diminish. Now, with data lakehouses coming back and ACID transactions on raw data, SQL is becoming mainstream again. And not just for the data processing, but also for ML. So on the ML side also, we are seeing that initially you had to know ML, write code in ML, and now they're seeing no-code tools for to generate predictions without any ML experience. And then finally, Gen AI has disrupted the market, and one may feel a bit lost in the forest of problems and solutions. It's really hard to wrap your head around everything now because so many things are going on. So, but it may help to look at it and structure it a little bit. Like at the bottom layer, there is purpose-built infrastructure. You have the NVIDIA chips and other chips and software frameworks like CUDA and all that. In the middle layer, you work with foundation models, augment them with different technologies like RAG, or customize them for new domains using techniques like PEFT. And at the top layer, you build or use Gen AI apps like chatbots or AI-powered assistants. So as things are moving, the work of the data scientists can also change. For example, LLMs can write SQL queries from natural language or text or create or even create visualizations just from natural language. So a data scientist who can provide good prompts to LLMs may become more productive than the one who is say a rock star in optimizing complex queries. And so that's so it's a very fast moving field, and things are changing fast. So data science, what is today, may be very different what it becomes tomorrow.
Thank you, Sumita, for your fascinating observation. Before we go further, we have many students who are watching live or maybe watch the recording. We have a question for them. What do you think the role of a data scientist in the industry? What they do? Sumita.
Okay, sure. So data science is a vast interdisciplinary field, and that really spans the entire life cycle of data. So it starts with capturing the data, and it can be any type of data. It doesn't have to be text necessarily, and from different domains. It could be logs from internet, from running services, or looking at internal traffic, internet traffic, or anything like that, video streams. And then making sure that, and then once you capture, making sure that they're continuously stored in a secure and correct fashion, cleaning and removing duplicates, analyzing them using predictive analytics, ML, or deep learning, and finally communicating the results of the analysis. So the range of responsibilities are quite a few, and usually one person, it's hard to really do all of these and be an expert in all of these. So slowly, it's in general in industry, we see primarily 4 different roles, and there might be other ways of classifying these things. So data analyst who analyzes the data primarily using Python or SQL, and build reports and visualizations to the owners of the data, company executives, business owners, line of business owners, and so on. The data scientist is a little more advanced role. So in addition to writing queries, they may prepare data, define features, create ML models, and publish them for others to perform predictions, or solve business problems with those models. Data engineers, on the other hand, they build and maintain data storage systems such as databases, data warehouses, or data lakes, and ETL, or data pipelines. What they are doing is they're making sure good data is stored efficiently, so that the analysts and scientists can use it later. And finally, ML engineers, they are building and maintaining AI systems. For example, and there are many range of things you can do, but for example, they make sure the applications that are built with integrated ML models, they continue to function properly or they continue to improve. So the skills that are required by these different roles, that may overlap. So one may start as an analyst and then move to become one of the other things.
Great. Thank you, Somidda. Let me go to Bangalore now from San Francisco. Chiranjit, you have been living in Bangalore for very long time. What do you see the things are happening around data science and AI in India's Silicon Valley, Bangalore? Chiranjit.
Thanks, Hassan. Yeah. Yeah, I think we are going through a peak period in AI and ML in terms of real usage. So far what you have seen, if you see the industry situation, especially in Bangalore, there are a lot of people who show interest and who try different models, who publishes paper and talks in conferences. But the real use in enterprise setup to realize value is something which was not happening in a full stream, correct? So we see that happening. I'm not saying it is happening just this year, but it is happening probably for last 1 or 2 years. And it needs kind of, how do I say, support from different parts of the market. People have to really believe that these systems are useful to reduce cost or to improve customer experience, or to create differentiators of other types. So that has happened, and we have been intimately involved because as part of our startup, we started 8-9 years back. So that time it was a huge struggle because nobody believed that enterprise AI will really provide value. And wherever we used to say that we have been able to predict this failure, we have been able to predict this intrusion, or all kinds of predictive things. People used to ask this kind of question: are you doing magic? You are saying before a machine fails, you will tell it will fail in next 7 days, and you are asking us to take action. So those are the questions which come because people really don't believe, or people don't see enough proof points. So what has happened in this last 7-8 years is that that proof points are created and people are seeing value. And as a result of this, the market for engineers, different types of how do I say, roles in AI has also changed. It is just not that people can create some model, or people can create TensorFlow or PyTorch and they can run some models. So that is slowly going off. People have to either become domain expert who can really explain or model or utilize a model in a specific situation, or they have to really be ML engineer who can think of newer ways of solving a problem to reduce runtime, to reduce CPU utilization, all of these. Okay, so this kind of maturity is coming, and since Bangalore is kind of very vibrant in terms of technology, we see this happening on a day-to-day basis. So in a very brief, it's probably we are going through a golden time actually, in terms of usage. Of course there are economic problem, there are sometimes we see slump, but otherwise we see a golden period in Bangalore.
That's great. Indeed, AI is the magic. Before we go further, I want to get one clarification. How is AI and data science related? How will we select one over the other? Chiranjit.
Okay, yeah. So of course, there is some gray area, but the focus, when we say data science, the focus becomes on data. When we say AI, focus becomes on intelligence. Intelligence means pattern recognition, generalization, reasoning, learning, all of this. And when we talk about data, we talk about modeling, and typically using statistical, because people are habituated to do that in earlier times. Okay, so now, but if you see, both either in technical ways or even from the market perspective, eventually, there is not too much of distinction, because, if somebody is good in, how do I say, linear models, using, ordinary least square, which they were used to use to do regression in earlier days, if they're very good at that, they will still be very good in even the current models, even using a recurrent neural network. There is a linear version of recurrent neural network which is very famous, and probably which is the which is in most use going forward, probably after this attention craze goes on. So if you think of underlying mathematics expectation from these two roles, it's kind of blurred, and the way we explain it, it depends on that. Okay. And if you think of market perspective, when somebody talks about role in data science and role in AI, yes, there are people who differentiate, who focuses more on a data part, when they call it data science, or more on, traditional modeling, especially statistical modeling. They call it, data science. But there are companies who typically, looking for an AI position, but they still advertise for a data scientist. They could always write an ML engineer, or they could, write something different, but they still sometimes write as a data scientist. So yeah, to summarize, it's just, the way people think. Okay. Eventually, if you go deep in one, you will reach the other, actually. Yeah.
Thanks, Yunjita. That's a very interesting field, actually. Now, let me go to our third speaker, who is junior to me. That's why I call him by his name. Ritendra, I understand that you are associated with several academic conferences. Can you please share your perspective and tell us how universities and industries are working together in this area?
Yeah, thank you.
Jitendra?
First of all, thank you so much for inviting me. I'm in the company of some great people, so thank you for thinking of me. I'm quite grateful. In terms of the question you asked around data science and AI and the industry academic collaboration, the thing that is happening right now, I think Shomita mentioned generative AI has been a game changer, right? So if you think about how it has played out over the years, between industry and academia in machine learning and AI, academia has always been at the forefront of innovation, because they've had the time and the money and the funding from various governments, especially the US government and the National Science Foundation, to drive innovation, and also specific European agencies that fund fundamental research. Academia has always been ahead of the industry when it came to fundamental research, like starting with support vector machines and so on, and of course much before that, the early days of neural networks, which has re-emerged as a very, very big innovation for the present day. But we are seeing a different trend right now. Like, the trend that we are seeing is the game has become a lot more about how much GPUs you have, how much like machine resources you have to train huge machine learning models. So right now, more than just the collaboration, there's actually been a shift from academia to industry in cutting edge research, because industry has just a lot more money and resources and access to machines to be able to do fundamental research if you look at sort of the one of the pioneering work around transformers that came out of Google, there were people that were attracted to Google who came from academia and started working full-time at Google and started working. And the reason they did were two things. One is companies like Google, Microsoft, Facebook, these companies had so much resources to fund these projects, and also they had a lot of data to be able to like really train large models that can actually make sense of this. So the collaboration is constantly shifting, and it has shifted quite a bit in the last 25 years from being primarily an academic pursuit with small engagements in the industry, small products, to much more primarily dominated by industry, and academia is sort of being left far behind. One of the things that's happening is the people in academia are kind of at a crossroads, especially in the field of data science and AI, whether they should continue in academia or move to sort of industries where there is plenty of funding to do this kind of work. And I think like the collaboration is more happening in the industry by attracting academia. Like, you know, you have a professor that comes, spends a sabbatical year at a company like, you know, Google or Microsoft Research, and, you know, innovating and then going back to academia, you know, getting their students and so on. So that's kind of
Awesome,
how I
great.
see it. Yeah.
Yeah, that's a related question. You did your PhD from Penn State. So what is the value of having a higher education in data science? How it gives a edge on one expertise and the career prospects?
Yeah, I mean, I'm a little biased because I went to you know, grad school to study computer science, and specifically one of the things I did very quickly was I was supposed to do theoretical computer science, but as soon as I entered grad school, I realized that the field of AI and machine, particularly statistical, at that time there was no neural networks, or the focus was much less, but statistical modeling based you know, and predictive systems was kind of growing pretty rapidly at that time. This was in, you know, when I just joined in 2004, straight out of college. I was extremely fascinated by that field. So that's my bias, because I was immediately blown away by the nature of the change from, you know, undergrad in Shibpur to like PhD in the US. There was a lot of change, and there was a lot of, having said that, the field is evolving so fast today that I actually would, if today I was trying to make that decision, I would think probably 10 times before you know, joining higher education. The reason I would do higher education is if I had gaps in my foundation of statistics, of computer science, of machine learning, of linear algebra. I would spend the time in higher education to brush those up. If I just want to be a practitioner of AI and machine learning and data science, I would probably see if I can find a job where I get to actually work on these problems with real data, with real people, with real problems. It's a little bit of a difference between when I started and now, because the field is emerging so fast. If you join higher education and you have a good foundational understanding and you have access to the right, if you got a job where you're actually doing it, you're probably going to move faster in your career just joining a job which exposes you to these things than going to higher education. So I think there's a very nuanced decision to be made based on where you are in your own personal journey, and because the choices are real at this point. It's not just like, oh,
Great.
you just need to do higher education to do machine learning and AI.
Got it. Yeah, thanks, Vijay. That's a wonderful insights. So we'll go to our next discussion for those who want to start their career in data science, freshers and the juniors. A question for Sumita. As a hiring manager, can you please share your experience and advice for selecting education path and acquiring the right skills for those who want to start their career in data science? Sumita.
Sure. So, you know, I don't, so I kind of think of myself when I was coming out of college at that time, how would I go into the job market? I'm sure things have changed quite a bit. But if I put myself in that time frame, we used to think of that, okay, there are certain areas and they do structured hiring for a bunch of folks to do a certain type of job. So data science, in my mind, and you know, this is what I am seeing. It's not this kind of a structured area that, okay, I'm going to do data science. I do these 20 things, and then I'm going to interview these 20 places, and I'm going to get my job. It's a little less structured. At least that's how I look at it. So, and the reason is that as a data scientist, you will still need to fit in a role in an org. So, and which can be engineering, it can be product management, it can be solutions engineering, professional services, applied science, and so on. And all these orgs have different hiring requirements and interview bars. And it also varies from company to company. Like what Amazon calls a data scientist is not probably the same as another company, what they call it by, because these terms are also, they get conflated quite a bit. And even within an engineering org, which is where I work, the situation varies from product to product. Some products that differentiate with the quality of their core AI, ML, predictive algorithms and improving them continuously. Now, in these products, they need domain experts. So often, somebody has an advanced degree in data science, those are probably the products that they will be looking for. On the other hand, some products, they assist, instead of building on core algorithms, they assist data scientists and to make them more productive and make their job easier. Now, in these kind of products, the real differentiation is not coming from the ML algorithm, but it's really coming from the intuition and subject matter expertise of the product engineers and the passionate internal testers. So those products will probably generally want engineers whose day job is software engineering, but who also have a fair amount of exposure to data science. So product managers for data products or ML products or AI-powered products, they need, on the other hand, a much broader subject matter expertise. So if you finally, if you have no data science and advanced degrees, you may fit in an applied science role. So there are many different types of roles. And I'm not saying anything new here. The meta point is that data science permeates many different roles. And so you kind of have to tune yourself for a particular role before you really want to decide what are the skills that you're going to develop. And then obviously, there's a lot of material on internet on how to prepare for one of those jobs.
Awesome. So in the interest of time, we'll move to the next question for you. There are a lot of things that are happening in the AI field. How will you stay up to date? What's your guidance there?
Yeah, so the thing is, the first off, and this is my personal opinion, and it may vary from person to person, create a very strong, a good reading habit. And but reading can be actually wasteful because there's so much stuff going out there. So instead of hoarding, this kind of trivia information, I know this, focus on intuitive understanding. So I'll give an example, right? If you see a mango tree and instead of counting how many leaves that tree has, just eat the mango and remember the taste. So these kind of things, that everything there is there for a reason. Why is it there and how it connects with other things? That intuitive understanding you have to build with all of these things. And if you do that, then you can build on top of it. It's sort of, you don't lose it. Like you learn one thing, then it becomes obsolete, then you learn another thing, and you keep going on like this. Instead, if you build on your intuition, then the skill is going to stay with you. The other thing is focus on breadth, at least initially, because there's so much going on that if you dive really deep into something, you might miss out on other things. So it's better to go look around first. And then finally, look for opportunities to practice what you learned with others. So build something, show it, build it together, discuss with others. And that is actually helps you to act out your thoughts and keep the momentum going. So, and also there are many things going on. So you have to be alert all the time. And if you're alert, then you'll find something. Like these kind of activities are not easy to find, but at the same time, if you keep doing this, then you're doing something durable as opposed to taking a course and going to the next course.
Awesome, great. We'll go to Chiranjeev Da. Chiranjeev Da, how one can start a data science or AI career in India, especially when they are fresh out of college or junior years? What opportunity you see in Bangalore and Indian cities?
Yeah. So I think, the opportunities are much actually. When we try to take people or look for people in ML role, especially, I have very, very bad experience, in terms of people who can really work or who can really fit into that kind of role. That is because I think Samita was mentioning that there are different kinds of roles, and people should not get confused where they place themselves. If somebody comes from domain expertise, so he understands how to formulate a problem as a data science problem. It's a different skill. If somebody comes from data pipeline kind of experience, so he understands how to create a data pipeline and how to create data which will be usable by the downstream AI systems. But if we look for people who can really think of, how to make this algorithm fast, or why this prediction is not accurate, or how can I work with less data but still get the same result, which are kind of fundamental questions. And there are just very few people. And this brings us to an opportunity that, if we are really looking ourselves to place, we must not fight with the, large groups of people who are chasing those activities, because there are just too many people who just know TensorFlow, PyTorch, and the statistical package, and they just know how to run linear algebra operations. Then they just don't know how to run some neural network. But that's an area which is absolutely crowded, and that's an area where what most of the companies are not looking for people. They're really looking for people which will substantiate or really augment their product team. So I see a huge amount of opportunity there, and I have absolutely very bad experience in terms of being able to find those people. So that's what I can say in Bangalore, especially. There are just too many people who apply, and if you just look at them, you just can't take any of them, because they just have some kind of package running experience, and they just know what is clustering, what is classification, what is PCA, and all of this. That doesn't actually help in terms of real product building.
Awesome. Great insight, Chinjida. Let me go to Ritendra one more time. How one should prepare and choose educational path for a data science career when they're in college or maybe in a few years in the industry? What is your advice?
Yeah, I'm a strong
Ritendra.
believer of learning by doing. I think this is again, I'm going to repeat myself. If our understanding of the foundational pieces that help you build a career is there, then you don't need to necessarily go back to, study or go back to take courses or certifications or even like advanced degrees. But if that gap exists, absolutely, for sure, go study the foundational pieces, like understanding linear algebra. In college, we sometimes underestimate some of those classes, but then they come back to haunt us because we have those huge gaps in our understanding. So it's good to sort of take that opportunity to, a few months to a few years to really understand the basics, then come back and apply them. So I think what Chiranjit said was very important, which is you don't want to have superficial understanding of AI and machine learning, because then you'll only have so much to contribute to an organization. It's better to sort of have such a good foundational understanding that if you have to go far beyond just running software that already exists in the public domain, getting some results, because as soon as some major change happens to what is expected from you, you get stuck. So I think the pursuit of different ways to build is going to be a function of where you want to see your career. Do you want to be a practitioner, or do you want to be able to solve any problems in that domain, or do you want to get really, really deep and change the field itself, right? So depending on your personal ambitions, you have to choose your career path. Like if you want to innovate in the field of machine learning and AI, if you want to work on generative AI in a way that actually changes the industry for everyone, you probably are better off really sort of spending some years in academia studying. But if you just want to practice, I actually don't think it's going to help too much to just go into academia and lose a few years that you could otherwise have spent in the industry working with real problems, with real data, with people that are constantly coming to you and telling you, hey, solve this problem, solve that problem. So I think like it really depends on the if you're really early in your career, my suggestion would be spend a year or two in the industry to see where the gaps are, to see if you need that understanding, and then make that call. But don't make an informed decision, because only you can decide where your career heads. and you can decide where your gaps are. Nobody else can decide that for you.
Very good suggestion, Sritendra. Now we want to switch to our next discussion topic for experienced alumni. We'll get to hear some experience from Shumida. Shumida, after your PhD successful career in VLSI, and you have switched to AI, and you are successful there. When you switch to AI/ML role, what are challenges that you faced? And if someone want to take that journey, what will be your advice for them? Shumida.
Sure. See, it's for in the mid-career people, it's there's no structured path. Even for myself, I didn't take I didn't decide to do something. It just happened. So I'll just give you. I mean, it's like a story. So I was more on the startup side of semiconductors. So what happens when you do that? You kind of have a front row seat as how the industry is evolving. So in around 2010, when we founded Wave Computing, what we're trying to do is build a data flow processor. And the reason we wanted to do it is because we wanted to solve some computational problems that could not be solved by general purpose processors, that are based on von Neumann architecture, right? So then there was no deep learning at that time. It was still 2 years before the Alex Krizhevsky's paper came out. But by the time our next funding round came, we're going and pitching to investors. We heard that everybody's talking about DNNs. So I looked at DNN deeply, and then realized that the data flow processing is an ideal use case for training these networks. So even though we had little prior expertise, we kind of have to kind of dig in and understand it well enough so that we can actually convince the people that are already experts in this area, to convince them that, hey, we can actually solve that problem for you. But later, once we got more into it, we hired our own engineers and built our own internal ML teams. So I had a chance to work with them. So now I'm working with people that come out of school knowing this, more mainstream folks, or may have industry experience. And I also took some online courses, and that is not to build the online courses are not good credentials. It's just to refresh my foundational knowledge, because as Ritendra was saying, that foundation is critical. You need to have your linear algebra straight, and all of that stuff. It has to be in place before you can do anything with this. And the field is evolving so fast that you have to remember that any product that you build today with these kind of skills, it can be obsolete in 2 years, and then you have to do something else. So as a matter of personal preference, and this again, I shifted to more durable problems. And what I mean by durable problems, like at AWS, many different ways are working on these fields. But I work on products that actually enable bringing all sorts of data reliably and securely to the ML algorithms, as opposed to products that apply ML to solve newer types of problems. So you can choose these things. So if you're making a mid-career switch, now for somebody, it's like really buying a new house and moving to it from the one that you currently own. It's sort of like that you need to leverage your current assets to secure the down payment and mortgage for the next house. So you cannot throw away everything that you have behind you. And so you have to give yourself some time. It cannot happen immediately. And the more the more curious and more humble you are, the easier it is. So I can give about 3 points on this. So first, you have to learn. You need a solid learning habit so that you build continuously. And by learning, I mean not software packages. It's learning the foundations. It takes some time, because we have all forgotten some of these things. And as Ritendra was saying, we probably didn't pay attention to this when we were in school. And I found that online courses are actually useful, are very useful, especially if they're taught by well-known people, because it kind of acts like an inspiration. It helps you to keep going on. And if you're a mid-career person, you probably in your company, you already have other things. So try to find an ML project, because maybe you can influence to start one. You can work with people, other people, so that you are kind of exercising and building at the same time as you are learning, and it helps. And the third is try to connect to people externally also, and ML practitioners. And you may feel that I really don't know ML. What can I do with these people? You can actually be creative there. These people know ML, but you have other things to bring in. Like, for example, you can start a volunteering project, right? There's people are doing the ML piece, but then you are doing the organizational piece, and that also builds a network and also builds confidence that you feel you try to find your footing if you try in multiple fronts, and then something will come out. If you're ready, some opportunity will show up.
Awesome. Thank you. Very practical advice. My next question for Chiranjeev Da. As Shumita said that you cannot leave your all current home, every asset behind. You need to bring them in. So related to that, what is that experience that a software engineer has, which he can bring to the AI field?
Thanks, Hassan. Yeah, I think that's one of the ingredients which is absolutely needed, okay? And people should understand that people who are coming from software, people who are trying to switch from software to AI ML, they already have one differentiator, and I'll talk about two other differentiators. Without knowing software, trying to become AI ML practitioner, to me it is very odd. Okay, of course there are other people in the industry who doesn't agree with me, but I feel it very odd, because most of the current generation algorithms are, cannot be done by hand, or it cannot be done by, small softwares. They really need, how do I say, a lot of software knowledge to be able to at least understand why something is taking time, why something is not working. So if you do not come from software background, we really lose out of that whole gamut of activities. So they have this. Okay, so they should always feel this. Now the other two differentiators, I think, as Samita has said, so I'll continue from there. So people cannot leave everything behind, what they were doing. If somebody is in construction industry, or somebody is in mechanical industry, manufacturing industry, they all have something useful. So the first thing is, we really need to think that if we are competing with a group of people, how do we differentiate from them? Because if we go along with them, our chances are reduced, correct? We will never be able to fight with these 100,000 people who are trying to look for a job, and they just have this curiosity, they just have intention, they just have knowledge of PyTorch and this statistical packages and TensorFlow. We do not want to go in that path, because that is the path of failure, correct? So we must create differentiator. The first differentiator we must create is trying to publish some paper, whatever it is. It may not be a very reputed journal, but when we took interview, we just try to find any signal of differentiation. That is the first thing we see. We just look through the resume and we see, okay, is this guy in some way different from the other guys? If we see at least this guy has written 2 papers and maybe the paper materials are interesting, that creates a differentiation. So that's the first thing which people can really do it. In this age, it is always possible to think of something new and try to publish something. Okay, so that's first thing. Second thing, which is lacking in this majority of the people who are trying to get into data science, is a solid mathematical understanding of something what they're talking. Not something about everything. No, we are not talking about everything. Even if we talk any guy that you are talking that you worked on this, do you really understand how this works? 99.9% will not answer that question, because they have not really gone. They have never created a backpropagation algorithm on their own. They have just learned about, oh, backpropagation is something which works in iteration, and that will help us to train. And it is possible for an engineer, especially from our college, they have enough intelligence to write backpropagation algorithm on their own. It just needs basic knowledge of differential calculus, right? So that is another differentiator which they must create. I think I'll stop.
Yeah, exactly.
And third point is that we must also create a differentiator in terms of programming itself. Most of the people do not really know how to write difficult programs like AI programs in some language. And in AI, typically, C, C++ or some native language knowledge is useful. So if we try to create these 3 differentiator, then probably we differentiate from others to have better chance. Thanks.
Some very practical advice, very practical observation. Ritendra, I have a question for you. How will you build a portfolio project, whoever working in the industry, that will make one marketable in the AI or data science field?
Yeah, again, I'm going to repeat myself. Learn by doing and build your portfolio that way. Like I've always believed in that. I've always sort of done that myself. So start small, build something, show that to your colleagues, friends, classmates, to your boss, and see if that is impressive. Because what happens is the reward for, like we say this in the industry, like the reward for good work is more work, not just industry, also in academia. The reward for good work is more work. You get something done, people get impressed, they give you more work. So you start a small, your portfolio starts small and keeps growing because you show success in everything that you sort of built. And then as you build, you get more work, and so you build more, and your portfolio gets richer, more more sort of wider in terms of the domains that you're covering, and also deeper. Like you go both deep and wide with your project portfolio. But I just also want to like share a couple of quick notes on like how I think about this kind of mid-career shift, right? So first of all, I actually think that it's never too late. You might surprise yourself what you're capable of learning. And don't give your age too much importance, because age the age is the mindset that you have, right? So never sort of give up based on your belief that it's too late to start something brand new, because you will surprise yourself if you try hard enough. Second is start somewhere and make progress. This is what I just said. Third is like be ready to invest some time, go slow to go fast, which means you should think about your career in if you remember integration, you should think in terms of the area under the curve of your next 10 years, right? So for some time, as you change your career, there will be a drop. It could be a drop in compensation. It could be a drop in you're feeling good about yourself because you were an expert in some domain. Now you're like a noob in a new domain. So you will go slow, but then eventually you'll go fast. And the thing to note is not sort of what you gain in the next 1 year, but over the next 10 years, what is the area under the curve of the impact, the money that you made, the influence that you had. That's how you should think. And finally, I think, you should be agile and open-minded. If something doesn't work out, you should be open to sort of going back to what you were doing before, which there's nothing wrong with trying and then going back to whatever you were doing, because not everyone is going to succeed, which is fine, because there's plenty of good opportunities everywhere, and you don't have to just stick to data science if that's not what you think. But with that sort of mindset, you'll be much more confident in sort of trying out this mid-career shift. So yeah, that's how I would end this.
Awesome, great. Before we go to our next round, there is a question from audience. Is Tallymark still useful in statistical analysis? Can you take that question? Ritendra?
I have no idea what that is.
Okay.
But I
Anyone
might be able
from-
to read up on it, and I have not. Yeah, I don't know.
Great. Maybe we can find it out later and update in that our YouTube description. We'll go to the next session for some question answers. For question for Sumita, what role you see the networking with other people played in your career transition, and do you have any tips for building a strong professional network in the AI field?
Let me see. So I'm not a huge networking person. I'm not the best person. I don't have a strong social media presence, but I'll tell you a couple of things. But networking is super important. But it can happen other ways also. Like personally, I often find myself, I mean, when I run into people, often and older or younger, doesn't matter. I often find qualities that I wish I had, or even sometimes I didn't know that I was missing that quality. And this motivated me to grow. And this is super important. If you're around people that you respect, you get a lot of incentive from that, even at an unconscious level. And in a practical level, what happens is that, I mean, I have been in startups, right? So, and most of my startup breaks, they came through networking, because when you're doing startups, it's nobody really puts out an ad and say, hey, I'm looking for the next person that I want to start my startup with. So it's really, the respect you have for people, and then the respect that give you back, and then slowly that network starts to build almost automatically. The other thing about networking, especially when this AI and these things, there's a lot of value. It is also a good tool that forces yourself out of your comfort zone, and this is mainly primarily probably more for mid-career people, because when they're in their world, they're well recognized and everybody knows them and so forth. But then there is this outside world, and how do you connect to that? So you really have to step out of your comfort zone, and you have to address your insecurities and vulnerabilities, because you will feel that, oh, is this person going to ignore me? And, because I don't have any credentials, and that's okay. Try and maybe you'll not get any traction, but then you'll eventually find people that maybe have some similarity with you, and it will click. And finally, I think the work that all the folks here, Hassan, yourself, Shapon, and Kalpana, and I'm probably not telling other people's names, but you guys are doing a great thing in building this alumni network. Because when I came to this country, 30 plus years ago, I didn't meet anybody from our college, for the first 5 to 6 years, and had this feeling that I have to go at Solar. If you came from, for folks that came from IITs, they had a much richer network, and the work that you're doing, it really helps. And so if you can reach out to this, and really, we all are connected with a common past, and we feel a tug, right? When it happens, feel somebody from the college and help out. So, try to take advantage of this network.
Awesome. It's a great advice. Actually, that was the motivation behind building this alumni network program. I will go to next question for Chiranjeev Da. How will I balance, or how one will balance practical hands-on experience versus theoretical knowledge? What is the limit? Like how much theory we need to learn versus how much practical hands-on I need to have?
Thanks, Hassan. Yeah, I think I'll share my experience in terms of when we set out to do something new or set out to build a product. If we really have to do something useful or something differentiated, we must go deep into this, and I'm not saying it is for everyone, but what I'm saying is that if you really think in that direction, that you want to create a product which will use AI as a differentiator, then you must go deep into that. And that deep, I have one suggestion that people may say that it's a huge domain, do you want me to do you want me to understand everything of linear algebra, everything of dynamical systems, everything of neural networks, different types, in all of this? No, that's not humanly possible. So whichever area we choose to focus on, we should go deep in that, and we should go in unconventional way. Okay, this is my way of working. Probably my unconventional way is go deep into the underlying mathematics. Read something which is not related with the current problem, but maybe remotely related with this, and you could find out something different. Think of solving large neural network problems using principle from statistical physics. Okay, you will see surprising ways of, how do I say, coming out with results which people never thought of. But this path is, how do I say, laced with difficulties. It is not difficulties of understanding mathematics, which is full of formalism. If you read one paper on mathematics, you must first spend many days to understand the formalism, which means what, how do they represent all of this. But if you cross that stage, even people will just ask you questions. Are you mad? You go into this detail to solve this kind of problem. So you must also be ready to tolerate that humiliation, that people ask you questions when you have gone that stage. But if you are able to stick to this path, then maybe eventually you will find something. So my suggestion will be, 80% of the time do what is needed, 20% of the time, or in weekend, read books in mathematics, read things from internet, and go deep in one area. Maybe you go deep in dynamical systems, which is closely related to neural networks, which allows us to explain the results of neural network. So go into that. So yeah, that will be my suggestion, that go just deep into one thing and you may get gold, after going through a lot many distance.
Very good suggestion, Chiranjeev. I have a question for Ditendra. As Chiranjeev was saying that we have to learn. The learning is a continuous journey. My question for you will be how someone will go about learning AI.
Yeah, there's so much online resources out there today. There's like these MOOCs, like large sort of online classes that there's plenty of websites have courses that are hosted that are free of charge. YouTube, where you're streaming right now, has a bunch of great videos. Don't underestimate the value. Make sure that you're picking good videos to learn from, because there's plenty of shallow courses and teachings as well out there. So you have to be a little bit careful about what you're specifically learning, who you're learning from, right? Andrej Karpathy at OpenAI, for example, has a fantastic 1-hour course on generative AI. Andrej Karpathy was one of the foundational engineers on the OpenAI team, and he sort of explains things in very simple terms, but he's very knowledgeable. There's also a bunch of professors who've started doing these online courses that I actually think that they are sort of much more up to date than like textbooks on AI and machine learning. A lot of the AI textbooks from when I was in grad school have become completely obsolete because they talk about boosting and support vector machines and logistic regression. Everyone has moved away from those early techniques of AI, and let alone expert systems and those much older techniques that even preceded that period of time. I would say focus on the latest and greatest, like read up on what's going on. Like the field is evolving super fast. Like generative AI in particular is evolving, like every single day we learn something new. And by the way, like AI, the big buzz around AI is generative AI, which is the idea that you can actually generate new content, whether it's text or images or audio or music or even series of actions. That's the big buzz, and it's here to stay. It's not just a one-time thing. It's because people get fascinated by creativity, and when AI starts to create, it changes the way. So one very
Awesome.
specific resource.
Just quickly wrap it up in
Yeah,
30 seconds.
yeah.
We are running
So
out of
one last very quick one that I would say is Meta has this course on training your own or fine-tuning your own Llama model. Basically, it's a foundation model, and then you use instruction fine-tuning to train a version of that actually works for a specific task. I would recommend trying that out yourself.
Awesome. So we almost reached at the end of our session. We'll just wrap up with the key takeaway. Maybe quickly, 1 minute, you will have to wrap up. Sumita, what are your advice and key takeaway from the session?
Yeah, just try to be so I'll take a step back. This data. Remember that we live in a context. I mean, career is a marathon, and we are engineers. And it's different from science or medicine because engineering careers do not advance monotonically. Expect that there will be ups and downs, and things that you learn will become obsolete. So it's better to it's wise to invest in yourself. And when I say that, it's not about just learning new things. It's actually increasing your intellectual ability to understand complex things.
Awesome.
That is something that is to grow, and also increasing your intuitive ability to perceive human reactions. This is something you'll need no matter what career you have as you advance your career, because if you don't understand humans, everything else is meaningless, really. And these two are permanent assets. And unlike skills and accomplishments, which are there, which will be the point in time and that will diminish over time, these things are going to stay with you forever.
Great. Chiranjeev, the quick takeaway advice from you.
Maybe just one suggestion from my side, that if people who are trying to get into data science or going up in the data science careers, if they feel that they have a real liking for mathematical models or liking to solve complex problems, I would suggest them that, they should definitely go for this. There are challenges in the beginning, but they will eventually succeed. But because they themselves feel that, they are better in understanding mathematical things or programming complex activities. So I will suggest them just go for it. You will find that you will solve it everything on the way. Okay, but you just need to be convinced that you really like this, subject, which is a combination of mathematical statistics and software and sometimes domain knowledge.
Awesome. Thanks for encouraging us. Ritendra, do you want to add anything on this?
Yeah, I would just say that, data science is one of many choices that you have in your career. Don't just jump the bandwagon and do whatever everyone else is doing. Try it out, see if you're passionate about it, and then decide whether you want to continue it. Don't do something because everyone else is doing it. You have an independent thought process around whether this is the right thing for you. There's plenty of things in the world that you can contribute to. Like the main thing is, where can you have the most impact, and where do you feel good about yourself when you have that impact? So if data science is that, we are all there to help and sort of provide resources and so on. But if it's not that, that's totally fine. Like, make sure you're open-minded about going in and going out of this field.
Awesome, great. I would like to thank all of our panelists, Sumit-da, Chiranjeev-da, and Ritendra, for sharing their wonderful experience and insights. This is really helpful for our audience. I would like to thank some of our pillars behind the session, Swapon-da, Kalpana-di, for driving the whole networking effort. And thanks to all our volunteers for making this session successful. And big thanks to all of our participants who have joined and will be watching. I will encourage everyone to join IISc Shibpur Alumni Network LinkedIn group and WhatsApp community and stay engaged with Alumni Network. The YouTube link is already published. You can check your Gabesu YouTube channel for the sessions, this one and all the previous ones. Thank you all. Have a wonderful rest of the day.